Hello guys, just a quick teardown and chat about these lithium polymer battery packs that are doing the rounds. We brought a bunch of these because they look too good to be true. We were rebuilding some mesh points that had 7 Ah dry sealed lead acids in, and obviously they weigh a ton, and for something that you've got to lug around, you want the weight down as little as possible. They then had a secondary battery in there which was 10 Ah. Sorry, wrong way around. The internal battery was actually 0.7 ampere hours. It was 26 volts and then 10 ampere hours on the external. So we wanted these to replace the internal and then another one, or possibly one of the 20 ampere hour battery packs of this type to replace the other one. And we got these, and I'm a bit uncomfortable about lithium ion technology still. We use 18650s in a lot, but we don't use lithium polymer a lot. Just too many horror stories, and you try and avoid using them because it's generally quite frowned upon to blow your customers up. But anyway, got these. Thought these are ace. So we've got a output here of 12.6 to 10 volts or 10.8 volts at 6.8 amp hours or 6,800 milliampere hours. We put this thing on test, and we had reservations about how this was going to go before we even started, and we instantly found fairly quickly found that those claims aren't very true. The voltages certainly aren't where you'd expect them to be. The battery pack doesn't cut out until the lithium polymer cells are well into the range where you don't want them going. And more importantly, we got more range of 2.1 ampere hours out of this. We contacted the seller about it, and the seller said, "Oh yeah, that's unusual." And it's a British seller, so he was great. He sent us 2 more. We tested 2 more. Same thing. He said, "Okay, there's something wrong here. He's been very good here helping us out. I'll send you one of the 20s." So we get one of the 20s here. We charge that one up. We test it, and again, third of the capacity you're expecting. So a quick dig around the web finds that this is not exactly uncommon with these, and a few of the Chinese sellers, where they've just basically fired them and left the customers to figure it out on their own, have got a lot of reviews saying that world is not the way as it should be. So I'm just going to quickly crack this one open because I know what's going on in here now, and I thought it would be nice if someone actually demonstrated to the world what's going on with these packs. So this one is charged, which is a really bad idea. However, the explosion containment bucket is outside at the end of my desk here, and I don't intend shorting this or doing anything stupid with it. I just want to show you what's under the plastic. Incidentally, yes, nice sharp scalpel blade, but you'll see, if it focuses, their end has gone on this one. That's deliberate, no pokey. Right, so what I'm going to do is just go into the end of this, and we will strip this down as much as we can without using implements, just because, well, we really don't want to poke this thing too much. So needless to say, this is a lithium polymer pack, so there are formers in here. For some reason, people like nice square batteries on these things. I'm trying to keep the blade where I can see it, because then we won't have any problems. There's been a couple of other problems with these as well. If you try and draw what the cells are capable of supplying off them, we've noticed we get huge voltage drops. There's also something really weird that goes on with these, but we'll cover that in a second. So, yeah, that's pretty much what I was expecting to find so far. Nothing unusual. Can we do this by pulling the tape off? Yeah, we can. So I've seen one of these that someone had taken apart where the inside was actually cardboard. It looks like we're fairly safe to get a little bit pokey in here. Will that come out now? Nope. can't see that to be happy about poking things into it. You can certainly get that one. Now, sorry, I keep moving out of frame. There we go. There is some glue in here, and things are spaced out. Now, the reason I want to take this apart is these are going to go into another application now. I need to calculate various things to do with the batteries, and there's actually more in here than I'm expecting. Or is there? Are they spacers? Okay. Oh, okay. There's something else going on here. Actually, this is somewhat worse than I expected. This is not what was found in the other battery packs that I've seen torn down. Now, if you're looking in here, you'll immediately see these look to the world, to me at least, like cell phone batteries. Now, I wasn't intending on finding this, which, yeah, I'm less than happy now about where we're going. I can also see the cause of some of the problems that we've had with these as well. So, these are hand built as well. So, what we have in normal use, you plug your charger in there. The charger gives out, will this focus? Come on, focus. 12.6 volts, which is a charge voltage, and then you've got apparently a flashing green light, which I've never seen, a red light for charging, and a green light for 100% charge. Now, this appears to be a current limited power supply with a comparator in. The comparator drives that little LED on the back. So, yeah, I feel slightly less happy about this now. Now, I had assumed, oh, the sun's come out now, let's focus back on the battery. I had assumed, which was a bad move, that there was protection circuitry in here. There may be protection circuitry in the individual batteries, but yeah, that's really not what I expected. But anyway, one of the problems we found is this, when connected, comes straight through to this. We also noticed that for anything to happen, even charging, you need this on. So in the equipment, it looked like we were going to have to just wire that on all the time. It means you can save the battery, but it's not ideal because this has to go outside of the case as a charge for the charge point for the customer, and this is wired to our equipment. But I don't really want to use this now. The reason we're having this problem is we have, that's not even electrical tape. I'm not taking that off. I'm tempted to save this battery now because I don't feel overly comfortable using it. So we're going to just quickly clip that one off. Clip that one off. Put that to one side and we can have a look at this mess. Let's just, I don't want to zoom in too much, my hands are horrible. So that is just masking tape. I'm going to find a solder joint and a resistor under this combustible masking tape, aren't I? Oh dear. Yeah. I'm not happy about that at all. Now, this wire here, and I am now completely destroying this, is quite horrible. If we take the output, it is really nasty wire. I mean, that's tarnished, and that, oh, focused on the wrong thing, focus. That is not going to carry the kind of current that it should do. Not good. And we've also got BX, don't recognise that. 3 amps, 250 volts. It's a reasonable switch, and we're only going to be pulling 1 amps DC through this at maximum, but still, yeah, not happy about that. I'm glad I did this now. Right. I know exactly what we're going to find in here without even looking. Having found that we are just reusing cased battery packs here makes this a little bit easier because I'm not quite so worried about puncturing them. Let's get rid of that. That is exactly what I thought I was going to find. These are cell phone batteries. It doesn't matter what we're saying on these stickers. If we can get these off. These are cell phone batteries. They look like Samsung Galaxy Tab batteries. And there. Now this is where the capacity issue is coming in. So already we've got a little bit of a problem here, because I only snipped one of those connectors and the other one's torn straight off. Don't know if you can see that. Just zoom in a bit. So yeah, that has just torn straight off. This one is not going back into service. I don't know that any of them are going back into service. And curiously, someone has made an effort to obscure the current. Now we've got 1650 milliampere hours there, so we've got 2 of these together. So that gives us nowhere near the capacity that we're expecting. Now what the theory is they've banked these up in 2s. Are these 2s? These are banked up in 2s. Pull that off. And we've gone out of focus. There we go. So we've got 3 banks of 2s. Bear with me a second. I just want to get some specs up in front of me. Now, any of you that know batteries knows that you don't count work current like this. Also, these should be balanced. Now, what's on here? You have standard voltage 3.7 volts, charge limiting voltage 4.2. That suggests to me that there's some smarts in one of these. I have no particular desire to crack one open, although it might be worth cracking that one open in a minute. So we have, I think that's 1650, 1650, and we have 3 of those. And those of you screaming at me do it in the head, not going to. Right, now that's interesting because that's not given me what I expected. Hang on, I've worked that out wrong. Worked that out completely wrong. Let's start again. Right, so we've got 1650. So we have 3 of these. Let's move this along. There we go. We have 3 of these, so that's how we're getting our voltage. So if we times that by 2, we've got 2 in each pack. That gives us a capacity of 3.3. Where's the shredded remains of the outer with that on? So that's about half. So what have they done? Let's just have a quick look, see what we can do here. So we've got 6.8 milliampere hours. 6800. Now if we divide by 3, that gets us the expected capacity of each one of these banks, which gives us 2.2 ampere hours. So yeah, So we're at least half the capacity that we're expecting. My suspicion is that what they've done... Let's try something else. 1650. No, that doesn't even work. My suspicion is that these are not the batteries that these were originally spec'd from. They've printed that. They've printed this. They've run with this, but they've changed the batteries. The general suspicion is that the way they calculate the capacity of these was to add the capacity of each one of these banks up. It doesn't work that way. You add the voltage, but the capacity is the capacity of... Trying to think how to explain this. So the voltages add up, that's great, and then the capacities add up when you parallel them. So series gives you voltage. If you imagine these are in a great string like that, so you go positive, negative, positive, negative, positive, negative. Well, I know that's wrong, but I wasn't looking. So coming across these, you get your voltage, but going across this way, you get your capacity. So the capacity is never going to be greater than two of these, which is the 3.3 that we've already calculated. So, yeah, where's the one that's open? I'm going to regret doing this. I'm going to put these to one side. The bin is over there, I can see that. There must be an easy way into these. Yes, there is. Camera looks like it's actually being helpful. Right, this is going to shortly become the sticker scalpel in the Lipo channel. Now I do need to be careful because I say these are fully charged. If this goes off in my hand, it's going to be unpleasant. So there is the Lipo. It doesn't smell like lithium, so that's a good sign. Ah, right. Interestingly, we've got something stamped on the battery here. 2017. So this battery is already old. 2nd of April 2018. 3.8 volt. Let's see capacity there. 2017 06 58 1650 160. That could be what we're looking for. Right, so we can't get anywhere in here. Oh yes, we can. Right, if I drop and run now, you know what's happened. And there we go. There is. You can't see it because I've gone off camera. Just pull this top back and you can see there's a connection there, and this is potted, so there is protection in there on a per battery basis. So we've got a number of problems with these. Let's just bring the pile of debris back in, zoom out a bit, make sure I don't go past my witness marks. There we go. So there we go. We won't just randomly pile these in. We'll have to be careful about where we put these because they might go bang. Yeah, utter bollocks. Right, so we've got several problems. One, that is a work of fiction. 2, 6 batteries in here. There is no balancing at all. These are Dodgey cell phone batteries that, as we've already seen, have been rebranded. Some of them were stickered. I don't think all of them are. Yeah, that one's stickered. And that one's stickered. Yeah. So, Dodgey cell phone batteries, we don't know the provenance of these. There are no manufacturer marks on these anywhere. We don't know who makes them. Each cell has its own protection circuitry. Yeah, I'll let them have that. There's no way of balancing these. The life on these is not going to be great. And quite frankly, I think I'd probably be better off making my own packs up from scratch. They'll do the job. If you've bought one, they'll do the job. I don't think they're dangerous as such. These connections are quite shonky, but You're soldering on connections that were designed to go into a holder. They were never designed to be soldered like this, so they're probably just pushed through the plastic or even bent around the plastic onto the circuit board. By heating them like this, you're melting the plastic. Yeah, I would say for little jobs you're probably going to be okay, but if you're going to do anything serious like we're planning on doing with them, yeah, you probably are better off building your own packs, and these will never reach the capacity that they advertise on the label. So I think we worked it out. Let's just quickly work it out again. If I'm doing these videos, I really need to stop the laptop from going to sleep. So yeah, we got, where are we? 3.3 ampere hours, or 3,300 milliampere hours. So that's half of that. So it's what we'd expect. I mean, our test methods aren't foolproof, so there's a little wiggle room in there. These batteries most likely do not deliver what they should do, so there's no way that this would ever reach the spec. So yeah, you have been warned. Purchase with care. Bye.